message. Sir, start చేసినా కొద్దిగా 10 minutes వెయిట్ చేద్దామా?
Good evening, a warm welcome to all participants to the 5-day National Webinar-cum-Faculty Development Program on Advanced Research Methodology and Data Analysis in the Digital Age, organized by the Department of Commerce from 22nd to 26th October 2024. Prayer song to commence our second day. Let us seek divine blessings. I kindly request everyone to mute their audio. Please join me in listening to a prayer song. I invite Sister Bhagya to lead us in invoking God's blessings through this song.
Precious Spirit, come. Holy Spirit, come. Come into me now to touch and heal. Precious Spirit, come. Holy Spirit, come. Come into me now and set me free. Oh, let my heart burn with love for my Lord. Let thy mighty power flow and set me free. Oh, let my heart burn with love for my Lord. Let thy mighty power flow and set me free. When times of trials come, temptations come my way, let me cling to thy precious love. Prepare me for the day, that great and glorious day, when my Lord comes back to take me home. Oh, let my heart burn with love for my Lord. Let thy mighty power flow and set me free. Oh, let my heart burn with love for my Lord. Let thy mighty power flow and set me free.
Thank you, Sister Bhagya, for that uplifting prayer. I am Dr. M. Sambasivudu, the organizing secretary of this webinar. Respected speakers, participants, and esteemed colleagues, it is a pleasure to welcome you once again. We are thrilled to have experts and scholars from across the globe joining us for this enriching program. Thank you for beginning here. Now it is my privilege to introduce our Day-2 speaker, CMS Dr. Jelani Basha V. He is a distinguished academic and authority in business, finance, and accounting, currently serving as a professor at Vijayanagara Sri Krishna Devaraya University, Ballari since 2019. Dr. Basha earned his PhD from Karnataka University in 2004 and has an impressive portfolio with over 110 national and international publications. His contributions to both theoretical and practical aspects of finance and accounting have garnered significant recognition. Moreover, Dr. Pasha is an active member of several professional organizations, including the Indian Commerce Associations and the Institute of Cost Accountants of India, reflecting his dedication to professional growth and collaboration in his field. With his extensive experience and passion for education, Professor Dr. Jelani Basha V continues to inspire students and colleagues advancing finance and accounting education and research. Okay, thank you.
May I continue, sir? May I continue?
Yes, sir. Yes, sir.
Yes. Good afternoon, all of you. Now I am Dr. Jilan Basha, CMA. I am from Vijayanagara Sri Krishna Devaraya University, Ballari. Now I am from Vijayanagara Sri Krishna Deva Raya University, Ballari. It is majority of the people are confusing with the Sri Krishna Deva Raya University, Anantapur. But our Ballari is a very adjacent to Anantapur. But Puram is a Sri Krishna Deva Raya University. SK, ours is a VSK, Vijayanagara Sri Krishna Deva Raya University. So I am basically from Andhra Pradesh. Now I joined my higher education in Karnataka for my studies. Now this is my brief introduction. Again, sir has also told about my brief introduction. Now I am coming to my topic here. Today I am going to deal with the data analysis. Now, data analysis has become more prominent in today's age. Now everyone is saying about data scientist, data analyst, data engineer, something like that people are saying. Now let me say brief about it. Data means, as all of you know, that it is a collection of information and recording of information. Data is broadly classified into various categories for the purpose of analysis. It is a must for everyone to understand the data classification in order to know what type of statistical tool to be used. Because if the data is something like that, if you use some other tools which is not suitable to it, the result may not be accurate. So that is the reason why we need to know the types of data. Now, when it comes to data analysis, types of data are broadly classified into two categories. One is a qualitative, another is a quantitative. When it comes to qualitative, there are two further subdivisions. One is, we can call it as a nominal data, another one is a discrete data. Ordinal data. Now, nominal data means it is a categorical data. Now, it is not in quantitative form, it is in the form of like gender, like male or female. It is in the form of like, for example, other categories, like it maybe you can call it educational qualification. Now this is what I'll show you slide. Now nominal data is a categorical data which can be categorized in the various forms, like it may be a gender, we can call it, maybe marital status, or it may be a types of cars, or it may be brand types. These are all we can call as a nominal data, which is not in quantitative form. When you want to analyze this kind of a data, we give some coding for that. Like for male is a 1, for female is a 1. This is the way we can code it. Now based on this coding, we analyze the data. Now another type of data in qualitative is ordinal data. Now when it comes to ordinal data, it is in the form of order. It is in the form of priority. Like for example, we can say education level. Now as you know, all of you know that education level, SLC, PUC, UG and PG, like PhD, these are all we can call it as a priority or ranking wise data which is given. Now it may be in the form of also like a Likert scale, what we can call customer satisfaction. Like we have a very satisfied, unsatisfied, like that. This is a what we can call as a ordinal data. Another type of category is a, we can call it as a quantitative or numerical data. Now one subdivision of this is discrete data. Now when it comes to discrete data, now here data is in whole numbers. Like for example, you may be asking whole numbers maybe in the form of your marks scored. Marks scored, this is in whole number. Now it may be a dice you are playing. When you throw a dice, there will always be whole number will be there. Either 1, 2 or 3 or 4 or 5 or 6. Like even if you take number of students will also be in the form of whole number. There are 10 students in one college, 15 students, in another college 20 students. These are all we can call as a whole numbers. Another one is we have a continuous data in the quantitative type of data. Now as you know, continuous data, it is in the fraction number. It will be in continuous number which will be there. Now it may be height of a student. Now we say height of a student is, we say exactly, we measure it and say. Now it may be, we can call it as a weight of the students. It is also, we never say in whole numbers, we say in a decimal or in fraction number. Or even in temperature also, we cannot say exact whole number. We say that in a very accurate number in the form of decimal. This is what we can call it as the types of data. Now, once we know the type of data, let us come to the statistical tools we are using. Now, what type of statistical tools we use it in order to analyze the data? When you want to analyze the data, I am saying here for today's lecture, I am taking descriptive statistics and inferential statistics. If time permits, I will go even for regression analysis using R software. Now, let us come to the what is a descriptive statistics. As you know, all of you, descriptive means it is a basic feature of the data set. Basic features of the data sets. This can be explained in different forms. Like means we can say that measure of central tendency is one of the means of defining the feature of the data set. That we are saying we are finding out the center of the data. That center of the data can be explained either by mean or by median or by mode. These are many other geometric mean is also there. Again, these are all various types of mean. Popularly we say here we use it mean, median and mode. Another basic feature of the data set is we can call it a dispersion, variation in the data. This also we can call, as I am a student of commerce and finance, I say that this is what we can call it as a risk, variation in the data. Variation or spread, otherwise we can also call it as a spread. Your data is a spread across the central tendency. One student has got 20 marks, one student has got 80 marks, one student has got 60 marks, because here the spread is wide. If the spread is wide, we can say more standard deviation. There is a more variation or there is a more risk, we say. This can be calculated with the help of various statistical tools. Like we say, small statistical tool, we use it in our measure of dispersion is range. Range is the most popular tool. We use it in a stock market for calculating now variance. Now, highest to minus lowest divided by lowest. We calculate variance of the data. If the highest to minus lowest divided by lowest, if you take it, if the variance becomes bigger, then we say this data is more volatile. The volatility of the data can be explained with the help of range. This is one of the small tool we use it in a stock market, considering our 52 weeks high and low, we take it. In every stock market, we get the data of 52 weeks high and low. The high stock price in a year, which has been quoted somewhere in a particular day, lowest price which is quoted in a particular day in a year, that highest and lowest we take it as a base in order to calculate the volatility of the data. Again, one more also we calculate like mean deviation. This may not be more refined tool, but thereafter we also use like quartile deviation. One more we use it variance. Variance is also another important tool we use it. That is what we can call as a summation d square divided by n. Summation d square divided by n, we use it in order to calculate variance. Now another most refined tool we use it in calculating measure of dispersion is standard deviation. The standard deviation, as all of you know, that summation d square divided by n whole root of it, we calculate -1. Now this is what we use it in our all analysis of research. We use it standard deviation in order to know the variation of the data or fluctuation of the data. This is another tool we use it in our statistical data analysis. Another one we use it as a skewness. Skewness means whether our data is leaning towards which side, whether it is the right side is more data is leaning, whether data is leaning towards the left side. This also we can call it as a symmetrical and asymmetrical of data. Now when you calculate this skewness, we get two types of skewness. That is what we can call as one is left skewed Another one is a right skewed. Right skewed we can call it as a positive skewness. Left skewed we can call it as a negative skewness. Now when it comes to here, skewness will help you to know how the data is leaning towards it. If for example, if I get for example positive skewness, then we say immediately mean is greater than mode, mean is greater than median, median is greater than mode. Is it clear what I'm saying? When the skewness is positive, we always say that mean is greater than median, median is greater than mode. This is what we say, this one. Now next one is we have left skewed, means it is a leaning towards more towards negative skewness. It is a leaning more towards left side, because we say left side means what you may be asking. Left side means tile is more bigger towards left side. That is called, we can call it as a negative skewness. Positive skewness means the tile is bigger towards the right side. Now when we get negative skewness, we say that mode is greater than median value, median is greater than mode is greater than median value, median is greater than mean value. Are you ready? Mode is always bigger than median as well as mean. The last one, another tool we use it in descriptive statistics, that is called kurtosis. Kurtosis tells about your data is whether it is a taller or thicker, or otherwise we can use the word fat, whether your data is a fatty or whether your data is a tall. Now in order to know this one, are you not getting slide up? Just wait. I want to clear my.
Yes, sir. But no change in slides.
No change. Just wait, sir. Just I'm doing it.
Okay, sir.
Can you? Is it okay, sir?
Yes, sir. Okay, sir. Now visible, sir.
Yes. Yes. Can you see
Yes,
this?
sir.
Yes.
Yes,
Thank
sir.
you. Now another is, we say that another tool of your descriptive statistics is kurtosis. Whether your data is a thicker or whether your data is a taller, for which we calculate this kurtosis. This kurtosis is also more important when you go for highly advanced statistical tools in order to know the symmetrical or unsymmetrical kurtosis to calculate. But here I am not saying much detail. Then wherever doubts are there, I can clarify when it comes to doubts. Now kurtosis are of three categories. One is mesokurtic, another one is a leptokurtic, another one is a platykurtic. Mesokurtic means your data is normally distributed. When your data is normally distributed means what? Here your mean is equal to median, median is equal to mode. This is a very ideal data. Normally distributed data is a very ideal data. This is highly difficult to get it. But still we say some example. Now for example, a student who has got score in all the 6 subjects, 60, 60, 60, 60. In all the subjects, when he gets a 60, then your mean will become a 60, your median will become a 60, your mode will also become a 60. So this is a very difficult to get in practice. That's why we can call it as a very ideal data. This is called normally distributed data. Now, when your skewness, kurtosis becomes mesokurtic, we say that your data is normally distributed where mean is equal to median, median is equal to mode. Similarly, now when your kurtosis is, we say leptokurtic. Leptokurtic means very peak, height will be there. It will not equally distributed both the sides. When you, this is a bell-shaped curve. When you cut the bell-shaped curve, half of this right is always equal to left side. May not be like that. It will be just like a more taller side, more peak will be there. That is called, we can call it is a leptokurtic. Another one is a platykurtic. Platykurtic means very thick. That's like a fatty man. Now here, this again you may be asking, sir, when it is there, what may be the result? Now we, as a student of finance and a teacher, I say that when I calculate, when platykurtic, when you get your data is, be clear, when you get your data is platykurtic, we say that less risky. when your data is what we can call like leptocurtic, we say that data is very risky. This is what we use it when you calculate in our stock market. We use it whether my data is a platycurtic, whether my data is a what we can call platocurtic, or it may be leptocurtic. Let me say once again. Now, when it is a data is a platycurtic, your data is a highly risky. When your data is a platycurtic plain, now your data is a less financial risky. This is what we use it when you calculate our statistical tools to be used when we analyze the data. This is what we can call as a descriptive statistics. Now let us come to the another important is inferential statistics. Now we want to draw the inferences from the statements we made it in our hypothesis testing. Now, when it comes to hypothesis testing, is broadly classified into three categories, we say. One is comparative hypothesis testing. Comparative. We want to make comparison between two samples, whether they are the same or different. This is what we can call as a comparing means of testing. This one. This is one type of inferential statistics. Another type is we can call it as a association. Association types of inferential statistics. Whether they are related, whether they are associated or not, whether they are related or not. That is another type of hypothesis testing we make it. The third one is we also make whether your data is influencing another data or not. Influence, impact we say. Like X is influencing Y. This is also another type of testing we make it in inferential statistics. Let us come to now broadly other way of classification of hypothesis testing is one we say parametric and non-parametric tests. Parametric and non-parametric tests. Now the question comes, what is parametric, what is non-parametric? Now I will say very simple. Parametric tests are those which fulfill some parameters, some conditions. When your data fulfills those conditions, then only we can follow parametric tests. What are those parameters? Let me say, your data must be independent. Your data must be homogeneous. Your data must be normally distributed. Your data must be linear. This is what we say when we want to calculate parametric test. Let me say whether your data is independent or not. Second one is whether your data is homogeneous or not. Third one is whether your data is normally distributed or not. Again, fourth one is whether your data is a linear or not. Now these are the tools we use it in order to, I'll say you later. Now to calculate, for example, homogeneous, we calculate Levin's test. In order to calculate the normality of distribution, normality test, we use Shapiro test or Jarko-Bera test. Now, for example, in order to calculate, for example, sometimes we also calculate, many are there, BP test is also, I'll tell you later those things. Now, in order to calculate, for example, linearity, we look at residual versus fitted line, we look at it. Another one, lack of fit test, we also calculate in order to determine whether your data is a linear or not. These are the parameters we look at it in order to determine whether to practice or whether to follow parametric tests or non-parametric tests. Majority of the research papers, when you look at it, we don't find this, they don't follow it. Rarely we find it. Rarely the people will use this test in order to say that I follow parametric test because of these conditions have been fulfilled. But we need to know it, how the data is independent, that all we must know it. Another one is a non-parametric test. When you don't fulfill this kind of condition for your data set, we go for non-parametric test. Another way of simple way I say, very interesting. Now in parametric test, we take it mean as a base in order to determine your data is similar or not. Let me repeat once again. Now in parametric test, mean is taken as a measure in order to determine whether your 2 samples or 1 sample or n number of samples are same or not. Mean is a base to compare the samples. In non-parametric test, when we don't fulfill those conditions what I said for, then we go for non-parametric. Here question comes, what may be the base we considered in order to determine whether the 2 samples are same or not, whatever it is. Now we follow here median is the base. In parametric, mean is the base for determining whether your samples are same or not. In non-parametric, we consider median as a base to determine whether your 2 samples are same or not. To prove your testing, high power testing. Another also we can use it rarely. Like for example, variance test, whether your data is similar in variances. Variance is also we can take it as one of the base in order to determine whether your data is similar in variance or not. That also can be taken, for which we calculate like variance test we use it, Levin's test we use it in order to decide whether your data is a similar variance in both the samples. Now let us come to the parametric test. Once we fulfill those 4 conditions, we can go parametric test. Now first we consider 1 sample t-test. T-test we use it. We use it t-test. In a t-test, we'll use mean as a base to determine whether the 2 samples means are same or not. Arithmetic mean are same or not. Now let us come to the t-test. They are of 3 categories. 1 sample t-test, we use it. 2 samples t-test, independent, 2 sample independent t-test, we use it. Another t-test is paired comparison t-test. T-tests are of 3 categories. One is 1 sample t-test. Number 2, 2 sample t-test, means 2 independent. Number 3 is paired comparison t-test. The question comes, what is 1 sample t-test? I want to compare my marks, my mean, with the average score of my class. The average score of a class is taken as a base, as a benchmark with which I am comparing my means of marks. That is called 1 sample t-test. My average, my mean score of marks, I am comparing with some benchmark. The benchmark may be average marks of the class, or average marks of the college, or average marks of the entire state, or something we take it as a benchmark. For example, when I want to calculate a returns of my security which I have purchased, I want to compare with the returns of the index. Index is a benchmark I am taking. Whether you can take it a BSE Sensex or you can take it NSE Nifty, whatever it is. You are taking as a benchmark. The returns of the Nifty is compared with the returns of the security I am holding. I am making comparison. This is what we can call as a 1 sample t-test. We use it 1 sample which can be compared with some base. That base maybe we can call it as a benchmark or whatever you can call, some identical base you are taking to compare it. This is what we can call as a 1 sample t-test. Now, the similar corresponding tests we use it in our non-parametric is Wilcoxon rank sum test we use it. When our data doesn't fulfill parametric conditions or parameters, then instead of following 1 sample t-test, we will go for Wilcoxon rank sum test. That is a similar test, we use it in our non-parametric test. This is what we can call Wilcoxon rank sum test. Now second, we'll go to the second category, 2 sample t-test. Now instead of taking a benchmark, I am taking 2 samples, 2 variables. I want to make comparison, mean of this and mean of this. You can compare shares, you can compare sales of 2 companies, you can compare advertisement expenses of 2 companies, You can compare GDP of two countries. You can take it. One sample is India's GDP, another GDP. You can take another country's GDP. You can make comparison. Two sample t-tests we are using. Are you getting? Mean of this and mean of that. Now what we are making, when you make, for example, statement for hypothesis, we'll make this one H0. There are two statements, we'll write it in hypothesis testing. One is a positive, another one is a negative. There are only two, quite opposite to each other. One is a null hypothesis, another one is a alternative hypothesis. What is null hypothesis? Very simple. Many people will make so much of confusion. Nothing. The means of A company is compared with the means of B company. When you compare, we say null hypothesis, they are same. Are you getting it? They are same. Mean of A companies is same as B company. You can state your statement as you like it, which is very simple in your language. Not necessarily that the fellow who has used something white complex statement, not necessary. It's very simple. The mean of X company written is as same as B company. Or you can also say it's not different from B company, mean of B company. A company's means written is not different from B companies or that of B companies. So that this is what HY is same. H1 is alternative hypothesis, they are not same. That's all. Mean with, when you compare, one may be the same should be there, one is H1, that is called alternative hypothesis. They are not same. Nothing but they are different. So this is what we are doing. Two sample we take, we make comparison. Mean of. So this is what we are doing. Two sample we take, we make comparison. Mean of this and mean of that. That is two sample. Let us come to the another one. Similar corresponding tests in our non-parametric. For that is Mann-Whitney, Wilcoxon, Mann-Whitney U test. The similar when your data doesn't fulfill the parameters of two sample tests, then we go for non-parametric. In non-parametric, the corresponding test we have, that is two sample Wilcoxon, Mann-Whitney U test, we use it. Now this is what second category of t-test. Now let us come to the third category of t-test. That is what paired comparison t-test. Paired comparison. We want to compare the only one variable, previous and past, previous and current. We want to make comparison. Now how this company before and after. Now let me take my own example. Now how my marks were before my UG, how my marks are after UG. We want to make some event as a base. That event is taken as a base. Now for that, before that event how it was, now after that event how it is. This is what we make. For example, trainings of the student or trainings of the employees. Now we take the data of trainings of the employees scored before training. Again same score after training, what are their score. We can make compare whether they are same or not. Variable is same, period is different. Variable is same, but only period is different. In previous cases, variables are different, period is same. Variables are different, period is same. But here, periods are different, but variable is same. Now we use it extensively this in our event study. There is a when we do our research, when we do it event studies, we take this one. Before merger, after merger, before announcement of dividend, after announcement of a dividend, before issue of bonus shares, after issue of bonus shares, before IPO, what was the market price of a share, after what is that. This is all we can take it as a event, then that event taken as a base, how pre and post we calculate. This is what we can call paired comparison t-test. This is what we use it in our t-test or parametric test. The similar corresponding test in non-parametric is paired Wilcoxon. Here also same Wilcoxon has been continued. Are you getting? For single sample also Wilcoxon is there. For two sample also Wilcoxon is there. For paired also Wilcoxon test is also. Similar we calculate. This all we can calculate in case of single, double. Now there is one more we have, that is called more than two variables. What we need to calculate? When we have more than two variables, like three variables, I want to compare the three stocks returns. One is Ultra Cement, one is ACC Cement, and one more is Gujarat Ambuja Cement. I want to take these are all three companies, cement companies. I want to compare the means of these three cements. Or we can take three students' marks scored in a particular subject, we make comparison. ANOVA, analysis of variance. This is the tool we use it when we have a variables more than three. Here also same hypothesis testing we set. HO is there is no difference among the means of the variables. There is no difference in the means of these three independent variables. In H1, alternative hypothesis, at least one of the means of this variable is different from other. At least one of the means of a variable is different from other two variables. That is what alternative hypothesis we use it. So here in ANOVA also we compare the means of more than two variables. This is what you can take here in ANOVA also. If you go advanced, is a one-way ANOVA is there, two-way ANOVA is there. For example, a three students of A college, a three students of B college comparing, like for example. Are you getting my point? Here you are taking three students, you compared in single one-way ANOVA. Three students means you have taken and compared. Like that, three colleges you are taking. Three students of A college, three students of B college, again three students of C college. This is what we can call it a two-way ANOVA also you can do. Like, because as you go more advanced, the complexity of interpretation is different. There may be sometimes interaction may be there. The interaction may not give good result when you go for advanced studies, so that we say one word in our statistics, parsimony. Parsimony is a word which we use it. Now try to reduce the number of variables so that you can make very clear in your interpretation and understanding. Because people are saying people will use it. Sometimes I use 10 variables, 20 variables for my research. Because when you take 20 variables, they're all conflicting with each other. That is what we use the word, one word, that is what collinearity, multicollinearity. They are fighting each other. They are not giving clear result. So that you try to reduce the number of, I am not saying reducing the numbers to the least. The appropriate number of variables are enough to explain your data very clear, very accurate. So that what I am saying, when you go for more factors of ANOVA, there is a more complex of interpretation. Why? Means there may be one college students, three students, another college, three students, they may have some kind of interaction may be there. One student of this college might have taught, might have given some inputs or might have given his notes to another college students, with which that college students might have got good marks. So that there is some kind of interaction when it is there, it has become very difficult to understand and interpret the data. So that if you ask me, as I know little bit of knowledge of advanced tools, I say that one-way ANOVA, at the most two-way ANOVA you can do it. You should not go beyond that. So this is what ANOVA we use it, analysis of variance. Again, similar test we use it in our non-parametric test is Kruskal-Wallis test. Kruskal-Wallis test. This is a similar test we use it when our data doesn't fulfill those parameters, whatever I said, 4 parameters, when it doesn't fulfill, we go for Kruskal-Wallis test. Some people, what they do when they write research paper, they use both. They use parametric and non-parametric. So some people, they don't use all parameters, what parameters to be fulfilled, they don't write there. Now these are all very important, but people directly they use it parametric. So all basic things what I said with respect to inferential statistics. Now another one is we have, as you know, Other way of classifying the statistical tools is univariate variable, bivariate variable, multivariate variable. Univariate means only one variable you are taking, you are explaining its features, you are explaining the data or describing the data. Now another is bivariate, is two variables you are taking as a variables, you are explaining their relationship. Two variables you are taking, explaining the relationship, whether there is a positive or a negative relationship, or a we can call poor negative or poor positive, or negative or strong positive relation, strong negative relation. This is what somewhat words you are using. Now this is the way how you are explaining. When you have this is what you know it, correlation. Correlation should always lie between plus or minus 1. Plus or minus 1. Now when you get 0, your correlation becomes a 0, then we can say that there is no linear relation, there is no relationship. So this is what we use it. Correlation is another tool. We use it in order to know the relationship between two variables. Even test also we can do. One way we can calculate the mathematical formula, we use it and to know what is the correlation value. Phi value we say, PHI. Phi value, what is a phi value? That may be point, for example 8 has come. We say that 0.8 if it has come, 80% of the relationship between A and B variable is in a particular direction. 80% of the relationship. Now this is what poor or strong, or this is a word we use it in order to describe the data correlation. Another important is regression. Regression is another, well, otherwise we can go for chi-square test. Chi-square test. It is a purely categorical data we take. Purely categorical. This is why I am saying means, but when it comes to t-test, there may be a what we can call discrete data we can take. Quantitative data is more, we take it there. But when it comes to chi-square test, we don't take quantitative data, we take categorical data. We take categorical data to use chi-square test. I'll tell you, chi-square test can be used in two ways. One is to determine whether your data is independent or not, or association or not. Whether the variables what you are considering, whether those variables are independent with each other, or whether those two variables are associated with each other, for which we use chi-square test. Are you getting? This is what we can call it as a test for independence or association. Whether they are independent means no association. Dependent means there is a association. Now question comes, how do you set the hypothesis for this? HO is no association, nothing but independent. HO, that is called null hypothesis. What I am saying, it is a null hypothesis says that there is a independence or no association between the two variables. Now H1 is there is a association, there is a dependence between the two variables. This chi-square test, we use it as some of you may be knowing where we use it. Like for example, a medicine which is given for a patients. The patients who are given medicines, the patients who are not given medicine for a particular disease. What will be the effectiveness? If there is a no association, means it has no impact of that drug on his disease. That is what for which we use it. This is a kind of for calculating this test of dependence or association, we use a contingency table. Contingency table, it may be a 2 by 2 or 2 by 3 or 3 by 3 or depending upon the type of the problem. Here I have taken an example of 2 by 2 we have taken. Male and female, yes or no. Yes, frequency, these are all numbers which are in frequencies which is available. Now we want to say how many yes they have said male, how many they have said with respect to disease. Having disease, not having disease. Yes or no. So this is what data we take, it will finally decide whether that effectiveness of disease we can calculate with the usage of the drug. This is what chi-square test we use it for test of independence. Another one is we also use this chi-square for the comparing observed frequencies with the expected frequencies. This is another method or another way of using the chi-square test. One is for test of independence, we use it. Other one is comparing your observed frequencies with the expected frequencies. You may be expecting all students in a college, they will get the same marks, 50, 50, 50. The observed, when you take the observation, one fellow has got it to 30 marks, another fellow has got 70 marks, another fellow has got 10 marks, other fellow has got 80 marks. This observed frequency and expected frequencies you are studying, whether they are same or not. Whether they are same or not. It is another method of or another way of calculating chi-square test. So I say that chi-square tests are used for two types of things. One is for calculating independence or association. Another way of using chi-square test is comparing the observed frequencies with the expected frequencies. This is a chi-square test, we use it. Another one we have finally the regression. As you know, all of you, regression itself is a big area. But when it comes to UG level, regression means we always say very simple regression, we use it. The regression may be a linear, regression may be a non-linear. But we teach at UG and PG level for our commerce student, we teach only linear regression. Linear regression. But when you go for, sometimes your data may not satisfy the linearity of that data. We always feel that the data is linear, but we don't find, sometimes data may not be linear. Linear means what? With the increase in one variable, dependent variable, with the increase in one independent variable, there is a proportionate increase in a dependent variable. We take here variables as a dependent and independent. In our previous test, we don't classify our variables as a dependent and independent. We classify only as a all are dependent, all are independent variables. In our previous test, like t-test, ANOVA or non-parametric, we don't say the variables are as a dependent and independent. We say the variables are independent. But here, when it comes to regression analysis, you should be very clear which is dependent variable, which is independent variable. If there is a dependent, one is a dependent variable, one is a independent variable, we can say that is a simple regression. One is a dependent, one is a independent. The multiple regression means one is a dependent, more than one is a independent variables. This we can call say multiple regression. Some may be asking, sir, if the dependent variables are many, now there are two dependent variables, two independent variables are there, we can call it as a, that is a multivariate techniques. They're all we are using advanced. Like example I am saying, let me say, repeat once again. When your data contains more than one dependent variable and more than one independent variable, then we use multivariate techniques, we use it. Multivariate techniques. Like example I am saying, structural equation modeling, SEM we say. Partial least square models. These are all advanced I am saying. Only for knowledge sake I am saying. Again, principal component analysis we use it. These are all again MANOVA. Multi-ANOVA. MANOVA also we use it. Multiple ANOVA also we use it. These are all tools we use it when your variables are more than one dependent and more than one independent. Now, Here when you take regression, the majority of the people they are doing only linear regression. But a majority of sometimes your data may not be suitable for your linearity of the data. Then when your data may not be suitable for linearity, then we go for non-linearity. Like there are many other advanced tools are there. We say, like for example, for your knowledge sake, I'm saying, like for example, I may be saying one example, like neural network. Neural network, we use it. Logistic regression, we use it. Logistic regression, we use. Lasso regression, we use it. These are all advanced tools. We use it when your data doesn't fulfill linearity. Now we use some tests, like for example, simple test. We plot a scatter diagram with which we can decide, visually we can decide whether my data is a linear or not. Sometimes we also use a lack of fit test. Lack of fit test, Box-Cox transformation test. These are all tools we use it whether my data is a linearity or not. Now these are all we use it in regression. Now these are all tests we use it. Once we calculate regression, we also calculate diagnostic test to support my data is my data is good fit. Now once when we calculate regression, I'll say you what are the parameters to be seen in order to determine that. For example, I may be saying one example. When we calculate those things using R, I'll say you later. Now, when you calculate regression analysis using any softwares, now we get a few results. Simple, I'm saying first one is we say that constant, that is called intercept, we say. Other way we also say in our finance area, alpha. Intercept. Are you getting what? Constant. Again, one more is alpha. This is what we say. This alpha, what it says. What may be the returns it is contributing to the dependent variable when all independent variable contribution becomes zero. When all independent variable, like for example, I have taken one example here. Now it is seen on my slide. Funds return is a dependent variable. Return of your particular stock depends on returns of a market and expense ratio of that company or size of that fund. These are all variables I have taken. Now, for example, other variables also we can take. Now, score of a student, for example, in your college, score of a student depends on many things. The score of a student depends upon the material he uses for his reading, depends upon the teachers who are teaching there in the classroom. Again, depends upon the friends he has in his classroom. Again, number of hours he is working every day. These are all factors which are influencing to get score. Now, these are all factors we can call as a independent. The marks scored is a dependent. So this is the data we are taking in a quantitative. We use regression analysis. Now, first, when you get the result, we get the first one is constant value. This is what we can call it as a alpha. This is more effectively used when we do it evaluation of fund performance evaluation of mutual funds. When we teach SAPM, security analysis and portfolio management, as all of you know that Sharpe model, Sharpe ratio, Trina's ratio, or even Jensen ratio, or Sartino ratio, information ratio, or tracking error. There are many more are there. There are many ratios we use it. Now, in order to determine which fund, which mutual fund is good, for which we look at one, when you calculate Jensen ratio, Jensen, Jensen, when you calculate Jensen ratio, we look at alpha. Whichever fund is giving more alpha returns, that firm is very good as per that model. So sometimes alpha is also is said it is nothing but it is measuring the manager's ability or internal ability of the firm is calculated or is understood from the alpha. Higher the alpha, higher the internal ability of the firm or higher the management ability of the firm. Other things we also look at it, the independent variables contribution. That contribution we look at it as a coefficients. Now there may be many independent variables may be there. Now each independent variable is contributing to the dependent variable. For every 1 unit change in independent variable, what may be the change in dependent variable? For every 1 unit change in independent variable, what may be the change in dependent variable? This is what we can call as a coefficient. Like how many independent variables are there, those many independent variables coefficients are given in the result. Now we say whichever independent variable is contributing more, for every 1 unit change in independent variable, there is a maximum change in dependent variable. If it is a, we say coefficient is high, so that is a more contributing. Now this is what coefficients we look at it, with which we can determine which is more contributing as a independent variable to that dependent variable. We are also ranking them, which is the best independent variable, which is a better one, which is good one, like that we also say. In addition to that coefficient, we also look at p-value. This is more important now. Everyone, whatever I am going to teach or programming, in statistics, the p-value is more important. Earlier, we used to calculate some statistic value, t statistic value, that is always compared with the table value. Earlier, we didn't have p-values in our softwares. We used to compare our calculated value with the table value. Then we are going to decide whether the null hypothesis is accepted or rejected, we used to say, with the help of tables. Now it has become advanced now. It is not necessary for us to refer any table, because we don't know what type of tables we have to see, because as the tests are many. Now t test there is one table, for z test there is another table, for chi-square there is another table. It has become very difficult for a researcher to refer the appropriate tables for it. Instead of that, we always look at p-value. What is p-value? It is a probability value. This probability value is always unanimously accepted at a 5% level of significance. P-value is always considered at a 5% level of significance. It's a unanimously accepted. There is no any hard and if you want to do it at 1% is not a problem. But by default, majority of the softwares, by default, it gives at 5% level of significance. It means what? It is a 95% of confidence level. 5% significance level is nothing but 95%. 100 minus 5, this will become 95% confidence level. If you calculate any test at 1% level of significance, it means that 99% level of confidence at which you are doing this. You are calculating this test. So 1% significance level is nothing but 99% confidence level. 5% level of significance is nothing but 95% confidence level. 10% of level of significance is nothing but 90% confidence level. This level of significance is very important, at which this level of significance will decide whether you are accepting null hypothesis or alternative hypothesis. This p-value is given in absolute value, not in percentage, like 0.05. The students who are researchers who are here, please write down 0.05 means 5% level of significance. He is doing his test. 0.01 he is doing means at 1% level of significance is testing the data. If you are testing the data at 5% level of significance, if p-value, be clear, if p-value is more than 0.05, if the p-value has come in your result more than 0.05, then null hypothesis is accepted. Null hypothesis is accepted. If p-value is greater than 0.05, null hypothesis is accepted. If the p-value is less than 0.05, less than, like if your answer has come 0.04, 0.03, 0.02, 0.01 or 0.000, something like that. If you get, if your p-value is less than 0.05, it means that alternative hypothesis is accepted. What is the alternative hypothesis? In t-test I told you, there is a difference between the means of A sample and B sample. If your p-value has come less than 0.05, as per your t-test, we say that there is a significant difference between the means of A sample and the means of B sample. Suppose the p-value has become more than 0.05, null hypothesis is accepted. What is null hypothesis? There is no difference. There is no significant difference between the means of A sample and the means of B sample. So this is a very important, this p-value has become more important in almost all the today's research. We don't look at other figures that may not be important, but for me important, for all of us, important is p-value. This p-value, we look at it. Whether that particular independent variable is significant, means if your p-value is less than 0.05, means we say the word significance. There is a significant contribution of independent variable to the dependent variable. In case of p-value of a particular independent variable is less than 0.05. Like that, how many independent variables p-value has got? Less than 0.05. Those many independent variables are significantly influencing the dependent variable. This is what p-value is a very important. One should basic knowledge of everyone. Now, in addition to that, we have one more that I'll say you later, these things when we get the data. These are all what we can call the basic theoretical knowledge of this data analysis. There are many more, because if you have any doubts, please, you are free to ask the doubts. Now here, let me ask any doubts if you have, then I'll go to my R software to how the software can be used. Have you any doubts, anybody, with respect to whatever I said now so far? If you have any doubts, please, you can ask. Then I'll go to the usage of software for all these kinds of tests. Any doubts? Anybody? Have you any doubts with respect to whatever I said? Please, you can.
Sir, voice is not audible, sir. Voice is not audible.
Yes, sorry.
Muted, sir.
Symmetrical distribution means your data is equally distributed on both the side. When you plot a bell-shaped curve, half of the bell-shaped curve are equal. That is called symmetrical, we say. When symmetrical is there, we say your data is normally distributed. Your data is normally. In curtaces, we say that this is a mesocurtic, we say. Mesocurtic. Any doubts you have, please? I'll go to software to be used, how the software can be used. Shall I go to software, sir?
Yes, sir. It was all clear, sir. It was crystal clear, sir.
Yes. Can I go further, or any other doubts are there? Please ask me, because later also I can ask you to question me. Then I'll go to next. Now I go.
Dear participants, please ask any doubts you have. Sir is ready to clarify your doubts. Okay, sir. We will move on the next session. Next topic.
Can you hear me?
Yes, sir. Yes.
Yes. Now let me say you about the softwares to be used. Is it visible?
Yes, sir.
Yes, sir. It's visible.
This is what R. It is a programming language. It is a open source software. It is integrated development environment. Here you come across here 4 windows. Here this is the first window, first section, that is called left top. This window we use it for source of information, for getting the inputs of the data for the calculation. Let me say once again, there are 4 windows in R Studio. When you download it, you will get this one, 4 boxes or 4 sections. Left top is a source of information section. Means source of information, whatever the data you are using, the data is visible here. Again, right, top right I am saying, it is what the environment section we say. Environment section. Here in environment section, about the objects, about the variables, you can find it. Even historical data is available there. In this section, historical data previously you calculated, that was also previously done, is available here. About variables what you are using, they are also available. This is a second section. In this section, we can also import data from the Excel or from other sources to get it into the calculation. There is one we have, I am showing here mark. This is a mark where we use it in order to import the data from the Excel. I'll show you later this. This is what another section. Again comes to bottom left. This is more important. This is all R version something he has written. Now this is the calculation section. We can execute the data here. Whatever data we have taken for our study from the top, from the left to top, that can be considered for our calculation in the left to bottom. Another one is another fourth section is, we can call it as a files, packages, plots section we can call. Here, whatever the files you have stored from your previous calculations are available here. Even whatever you are plotting, your graphical representation is visible here. I'll show you. Graph will come on the bottom right, will show all the graphical representation. Again, packages means here question comes, what is packages? Here there are some packages we need to download it in order to do a particular calculations. In one package you cannot get all the calculations. The statisticians are the community which is developing here this software. They have not developed everything, all types of calculation, right from the top to bottom, from the pin to plane, all calculation cannot be done in a particular package. They are developing different packages for different tools. There may be some basic packages which are available, no doubt, like LM test, some basic packages which are available. Like for example, if you want to do data visualization, if you want to display graphical representation, we use ggplot2 package. We use it in order to visualize our data. So that there are n number of packages, are 50 to 60,000 packages are there. These packages are for different disciplines, not for commerce. For physics is there, for chemistry is there, for biology is there, for mathematics is there. Different packages are there. So that sometimes those many packages may not be available. We need to know some basic packages which are required. That I will tell you which are those basic packages with which we can make calculations. So this is one way of packages which are needed in order to calculate a particular type of a tool to be calculated. Now let us come to simple example. Now I am using. Now this is what left bottom section is for executing the data. But here it has commands. You need to work something on this. These are all commands are case sensitive. If the command is in capital letter, you have to write capital letter only. But once you understand, probably basic commands are quite easy to understand. Like for example, I am using, just see. Now I want to use it basically primarily descriptive statistics. Are you getting point? Now example I am saying, example I am writing. A is a variable. A is equal to, this is equal to is a mandatory here. Is equal to is a mandatory. A is a variable or A is a variable. These are all the observation which are stored. A is equal to C. C means combination. Is a technical term, something is there, concatenate, something like that is like that it is there. C means. Simple way I say that C here nothing but combination. A is a variable which is a combination of these variables. Here round bracket is more important. Brackets are very important. Commas are very important. These are all very interesting to understand. A is a variable I have created. In this variable I am writing some observation. Example 45, 23, comma. For every observation there must be comma. 65, comma. 85, comma. Again 12. Simple. I have taken 5 observation of a variable A. These are all observation are stored in the first letter, that is called A. Now, just after that, you can just enter it. Once you enter it, when the arrow mark comes, your command is correct. Are you getting? Let me repeat once again. Once A is equal to C, something you have written. Even you can also download the data, not necessary to write here. Even download the data, direct download data can be used. This is what I have written. How you say your command is correct? When you enter it, you should get a arrow mark. When you get arrow mark, your command is correct. So that you can do further things. Like I am going to next one. Mean I want to calculate. MEAN. Same is it. Mean I want to calculate. Mean I'll write it. In the bracket, I'll write the variable. What is the variable? A. Just I'll click it, enter. Answer we got 46. I have taken the command or whatever you can call syntax or whatever you can call code. Mean is a code. You write mean. Within bracket, the name of that variable you should write. Name of the variable is A. Then you got 46. Are you getting it? Like same median. Same MEDIAN. All in small letters is A. Take median. Same. Bracket it comes. In the bracket you paste it your variable. A variable. Just you click it. You will get 45. These commands are very important to know. I'll give the list of it if you want after my lecture. Now, for example, standard deviation. Standard deviation command is SD. SD you type it and put the bracket. In the bracket you write your variable name and click it. 29.86637. Now, if you want to calculate instead of that something like, for example, I want to calculate coefficient of variation. I can calculate CV. CV is equal to mean divided by median. Mean divided by median also I can do it. Are you getting it? Mean divided by mean also I can do it. That figures I can take it 46. I'll write here. Divided by 29.86637. If I do it, if I calculate, CV is correct answer. When answer is correct, what is the answer? CV, if I type it, I'll get the answer. CV is a 1.55554. CV is used to calculate consistency. Lesser the number, more the consistency. More the number, lesser the consistency of a data or stability of a data. Mean divided by, here standard deviation by mean I should take, if it is there, if I take mean as a numerator, if I take a highest number will be the more consistent, lesser number is a less consistent. Now I should take standard deviation, correct. Even if you take this also, it is not a wrong. Instead of taking standard deviation divided by mean, if you take it, lowest will be the consistent, higher will be the less consistent. If I take mean as a numerator, higher will be the more consistent, lesser will be the less consistent. Now if I take, for example, standard deviation 29.86637 divided by, directly I am using, divided by 45. 0.66. Now both are same. Both are same answer. It will give, if you take a 10 companies, if you calculate the coefficient of variation, the most consistent means lesser. Standard deviation, if you take it as a numerator, then lesser figure will be the more consistent, more figure will be the less consistent. When standard deviation is a numerator. When mean, if you take it by mistake as a numerator, doesn't matter. Higher will be the more consistent, lesser number will be the less consistent. Now, like for example, I want to calculate one more tool, minimum. Now Now minimum, if I take it, again minimum I take it, again I'll write it a variable name, then I'll just click it. 12 is a minimum number in our observation. You see, minimum, what is our minimum number? In A, minimum is 12 is there. Minimum is 12. Now maximum, if you want max, these are all codings you should know. Max is a maximum. Now write it a variable I want for which I want to calculate, then max. Range, if you want range also you can calculate range. Now a, then it will give answer. Now minimum and maximum. Now for example, if you want to calculate skewness, if you want to calculate now a variable, skewness S, otherwise I'll tell you later. This one skewness, something I have done wrong. Let us come to the sum. I'll say you later. Just wait. Sum total. If you want to make it, you can take a, then you do it. Sum of this. Like that you can do. No sir, I want to do it whole. Like descriptive statistics as a total. If you want to calculate, we say summary. 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 If you take it. Now a variable. If you click it, then all minimum has come, first quartile, median, mean, third quartile, and maximum. Now in this package it is there. One more packages we have. Describe is one more package, psych. In that packages, when you do this one, you will get many more. For example, for your knowledge sake, I am saying, when you want any package to be downloaded into calculation, we say the word library. Once you package download from the outside, to into the system, we say the library. Install the packages, we use it. From your outside, you that is what there is a separate we have where the packages are available. It is available, R packages are available in our R packages. There is a separate website is there, R, where you can download your packages. I'll tell you one simple, I'll say later. Library, for example, library. This is what the package which has been stored in a C. Then I am taking into the calculation. C, for example. Describe describe is not there. I have to install the package. Install. First I am installing packages. Now one is package we can call it psych, P. So for psychology, people will use this package. All calculation which is available here. Just I want to install this package in my system first. First I have to install my package into the system first. Then I have to take that package into the calculation. Once it is installed, then it is installed. Now package has been installed. Now I am taking that package into the calculation. When I want to take for the calculation, I use the word library. Library, I use it. I take that library. I take library. I download it for calculation. What is the package name? Psych. PSYCH. I am using. Now it has been taken for calculation. First, installing the package into your system. Then from the system to you have to take it for your calculation for RStudio. Now I have taken. Now I am calculating. One command is there in this mini example. It will give describe. Describe A data. Just see. Here many more calculation has come. Here many calculation he has given. What are those? One is variance, number of observation, mean, standard deviation, median, trimmed mean, again mode, again minimum, max, range, skewness, curtaces, standard error. In this command we'll get many, but in simple command summary we'll get only few, like minimum, first quartile, median, mean, third quartile, maximum. So this is what we use it for describing my data. When I want to write an article, initially, now I take the data. First, I'll use descriptive statistics, wherein I use mean, median, mode, standard deviation, variance, minimum, maximum, range, skewness, kurtosis. These are all I use it. Now, if I want to plot, this. I can plot it. PLOT. Plot means diagram. Plot, I write A. Now, variable, then just type. If the plot is, the figure is, margin is too large, just wait. Plot.ts. Now this one. Plot.ts, if you draw it, now I told you, this is a section which is meant for displaying your visualization. Very beautiful visualization, I'll show you later. If you want to give color, sir, I want it in color, means again for the same command, I am writing color here, comma, COL, color is equal to color blue. If I want blue color, BLUE, blue. Color, variable, data name is A, variable name, comma. This every argument you should compulsorily write the commas. COL, color is equal to blue color. Just I am writing. Now color has come. Just see, blue color has come. If you want some other color, if you want, you can write red. Red you can write it. What is it? Red if you want. There are n number of colors are there. There are countless number. Color has come. Red. Even if you want headline, for this you can make it headline, comma. Main we use for headline here. What is the code? Code is main. Main is equal to. Now it is a title. Here what is that headline title I am writing. Now something I want to write. This is a time series data of A variable. Time series data of A. This is what my title of this data. Now title has come. Time series data of A. So this is what I am describing the data using commands. Again, I am also using plot. Even I can use skewness, all these things. I told you, if you want to mean, what is that? Mean, that I will say you later. This is what we can call it as a simple descriptive statistics. Now come to the inferential statistics. Testing we are doing. Here we are taking t-test first. Simple parametric test we'll see. Thereafter we'll go to the non-parametric test. Then we'll go to the regression if time permits. If you're all patient enough, we can go ahead. Otherwise, it is you. But it is a beautiful software. Now advance has come. Now we use SPSS, we use eViews, we use SAS, we use Python, we use R, we use many other have come. It is you to decide. Now Python is much more better. I never say that mine is good. But Python is something different. Now it is also equally popular in the world. Now that's one reason why I am practicing. Now let us come to the inferential statistics. First we will go to the parametric t-test. Same test I am taking, same test variable. Now what is the command here? T-test, t.test I am writing. Open the bracket. Now before the bracket, whatever you write, that is what we can call it a function. Function. Function is very important. When the function, what you write is wrong, your answer doesn't, just like a error will come. At the top I told you, plot A, error, how it has come? It means that it is wrong, it says. So that you will come to know there itself whether your command is right or wrong. So this is the best way of knowing it. T-test. Once you write t-test, open the bracket. Now question comes, sir, where we have to open round bracket? Immediate after the function, you have to open it. These commands you should compulsory learn, because though I am a student of finance or commerce, I am not a software engineer, I am not any programmer or user, but out of my own experience and practice I learned it. Now I am writing function A, variable I am writing, comma. Now I told you when it is a single sample, A is a single sample, only one sample is there. I can compare with any other benchmark mean. For benchmark mean, we say that mu we say. Mu is a benchmark mean. We write it, mu is equal to, we write it sum. Here for example, actual mean has come how much? Actual mean has come to 46. Actual mean has come how much? 46. Here also there also. What is actual mean? Actual mean is 46. In our other language also we calculate actual mean is 56. You want to compare mean is somewhere benchmark is for example 25 is a benchmark. In one college the average marks of the students is 25. Your college marks you got it from A. Then you want to make comparison whether the marks of benchmark is equal to or similar to or same as your college marks. That I am calculating. Just see the data has come. Answer has come. What is that? One sample t-test. Here are many are there. It's all very interesting. But if I go on saying, you may not much because all cannot be understood at one shot. So that I don't want to say many things. Here most important I told you p-value. What is important? P-value. P-value I told you. What is a benchmark? What is a confidence level at which all of them have been accepted all over the world is 5%. 5% is nothing but 0.05 in absolute value. Absolute value 5% is nothing but 5 divided by 100. It comes answer as 0.05. You are comparing 0.05. It's by default all softwares will give. Even it has been given here. 95% confidence level he has written also. This is what software has calculated this answer at a 5% level of significance. Now 0.191 has come. Now you are comparing with the 0.05. Your answer has come more than 0.05. Your p-value is more than 0.05. It means your null hypothesis is accepted. If somebody has not understood, please ask me question. I will answer you. Now your p-value is more than 0.05. So that null hypothesis is accepted. Any p-value more than 0.05 null hypothesis is accepted. Nothing but HO. HO. If your p-value is less than 0.05, alternative hypothesis is accepted. That is called symbolically H1. Here your answer p-value is more than 0.05. Null hypothesis is accepted. What is the statement you are writing for null hypothesis? In case of t-test, there is no significant difference between the mean of a variable and its benchmark mean. Let me repeat once again. H0 is equal to, I am writing, this is what statement. There is no significant difference between the mean of a variable and its benchmark mean of 25. That is what you are saying, there no difference. You have accepted no difference. But if your answer, if your answer had come less than 0.05, you would have told there is a significant difference between the means of a variable and its a benchmark. This is what we are saying in a testing. This is what result of it. This is what we can call it one sample t-test. Now you may be asking, sir, I want to test it at confidence level, not at 95. I want to test it at 99. You can do it here. One more argument you have to add. What is the argument? After mu, you have to add CONF, confidence level, is equal to 0.10. At what percent? If you want to calculate this test at 1%, if it is there, it means that 99%. 90, 0.99. 0.99. You are calculating this test at the 99% confidence level or 1% significance level. You are comparing with the benchmark mean of 25. Now let us see what may be the answer. Now just enter it. Now entered, answer has come. One sample t-test at 1% level of significance. You see here, 99% confidence level you are looking at. At 99% confidence level, your p-value has come 0.191, same has come. Now, so that again you are saying that there is no significant difference between the mean of a variable and its benchmark mean even at 99% confidence level or at 1% level of significance. No, you are doing. Again, this is what we can call the N1 sample t-test. Now you want to do two samples. A is also there. I want to write it one more variable here itself. Again, B is equal to C. When you want to write the data, be careful. B is equal to C, collection of B variable. You can give any name, be clear. Whatever you write the first command, any name you can give. What it says, simple. Whatever the observation you are taking, that observation are stored in the name of B variable. That is the meaning. That's all. You can write B. I have written many times my university name, VSK. I can write my name, sometimes Jila. Sometimes I write my own mother name, father's name. You can write any name that. What you write first, there is no any hard and fast rules. What it says, whatever you are writing, in that your all observation are stored. Your observations are stored there. Now I am writing now some number. Now this is what data I am writing. 12, 56, 1589, something like that. Something I am writing. How many observations there? Top 5 is there. 5 you have to take. It should be balanced data. It should not be unbalanced data. Be clear. When you want to make comparison between the means, all the samples have the same number of observations. You cannot have more than that or less than that. So that I have taken 5 observation. I am writing one more observation. Now this is what my data. Now I am writing. B is correct. B, the observation have been stored in B variable. Now I want to calculate t-test. A and B. I am comparing the means of A variable with that of B variable. I am comparing the means of A variable with that of B variable. What is the hypothesis I am setting? HO is equal to null hypothesis. There is no significant difference between the mean of A and the mean of B. This is what my statement HO. H1 is quite opposite. There is a significant difference between the mean of A and the mean of B. This is my hypothesis testing. Now I am calculating. Again, same command. Test, t-test, same command. You need not worry. T-test, open the bracket, write the first variable A, comma, B variable. It means 2 variables you have taken. Now, if you want to write, you can write something. Otherwise, no problem. Just I am clicking it. Now, that task. See. Now, 2 sample test. Test AB. Now, mean of X is Y. 2 variables mean has been given. Now, let us go to the p-value. P-value is very important. I told you. This is more important. Again, I told you p-value is more than 0.05, so that null hypothesis is accepted. When it is accepted, what does it mean? There is no significant difference between mean of A variable and mean of P variable. Hence, null hypothesis is accepted. This is what we are saying. Now, question comes. Now, for this, there is a one condition we have. Very interesting. When you calculate t-test, there must be equal variance. That is what I told you, one condition. Homogeneity, you say. Homogeneity of data. Homo means same. Homoscedasticity word, the correct word we use it, homoscedasticity. One of the parameters for fulfilling the parametric test is homoscedasticity. 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 Homo means same. Scedasticity means different. Variance, actually, sorry. Homo means same. Scedasticity means variance. Same variance. We use assuming that this data is different. This data. Welch test, we use it. Welch sample test, we use it when your variance are different. By default it comes. Now you are saying, sir, I calculated variance of both are same. When that is there, you can add one more argument there. What is the argument? Here after this again comma, VAR, variance, equal. Variance is equal to equal. Variance dot equal. Sorry. Is equal to true. TRUE. I'll give comments. You need not worry. Some comments I'll give you so that you can make practice. You will enjoy it. T test I have written. This is a function. Open the bracket. A variable I have written. B variable I have written. Variance dot equal is equal to, this variance are equal. So I am saying true. Now it has been, people are using now very shortcut. Instead of writing TRUE, people are writing only T. That is also correct. Much more advanced now. Now I am saying this one. I am calculating using now error, true not found. These are all in capital letters. This should be there. I have made a mistake. Now that my command is wrong, I'll go to capital letter. All should be capital letter. TRUE. Now command I am writing. Now data is right. Now what it says? Now here two sample tests. It is not called Welch test. Welch sample test is used for t-test when your data's variance are not equal. Here your data variance are equal. It is called t-test. Now here we will look at it. 0. Here also same answer. There is no much difference between the parametric and non-parametric answers. Almost it will be closer. Almost many times. Even if you try both also no problem. Here you are using, here this test corresponding you also do Wilcoxon test. I am doing Wilcoxon test. Let us see. Here Wilcox test. Wilcox dot test I am using. I told you A single sample I am using. A comma mu I have used is equal to 25, I think so, maybe. Now the answer has come. Wilcoxon signed rank exact test is a corresponding non-parametric test of single sample t-test. What is the answer? P-value has come to 0.3125. I told you, when your p-value is more than 0.05, null hypothesis is accepted. Is a very important p-value. I have been saying you this p-value. Now when your p-value is more than 0.05, null hypothesis is accepted. And null hypothesis is accepted, what is your statement? There is no significant difference between the mean of A and its benchmark mean of 25. This is what you are saying. You can also use the same Wilcoxon test for two samples. I am using Wilcoxon, same Wilcox. The command is Wilcox test, dot test. Then A comma, B comma. No, if you want to give confidence level, you can give. Otherwise, not necessary, you can just A comma B. Now here we can, the answer has come. What is the answer? Wilcoxon ranks some test with continuity. Now what is the p-value? Go with the p-value. P-value is equal to 1. What it says p-value? When your p-value is more than 0.05, no difference. They are same. Now here, some warnings here and there comes. When data, sometimes when it is not suitable to it, with small changes, when your data may be sometimes missing, your data may not be cleaning, your data may not be properly designed, this will come. It doesn't mean that it is wrong. Be clear. Warning message doesn't mean wrong. It says that if you had used this kind of a data, it would have given much more correct, no doubt. He has clearly given. What is that warning message? You cannot compute exact p-value with this. He is saying. No, it doesn't mean that you are wrong. Your command is right, but only data what you have taken for which may not be suitable, it doesn't matter. So this is what you can do, Wilcoxon. Now let us go to another test, paired comparison t-test. I told you what is paired comparison t-test. There are two events for the same variable, before and after, pre and post. Pre and post. This is what I am taking. How what was my salary before professor? What is my salary after my professor? What is my efficiency before professor and after professor? You can take any event. There is no need to say n number of example you can give. Some particular event you take. Budget. Before budget, what was the GDP? After budget, what is the GDP? Before formation of government, your Telugu Desam. Before formation of Telugu Desam party, what was the GDP of Andhra Pradesh? And after. You can take any event is very important. You demarcate one line before and after. Now, for which I am calculating. Again, same t-test, t-test. The function remains same. Open the bracket. Here again t-test for two event. I am taking event remain same. A is a before event, B is a after event. I am assuming here. Again, don't get confused. What, sir? For that also you have taken there two different. If you want, I can give another example. If you are confusing, if you say that assuming A is a before event, B is a after event, we can do with the same that answer. What is that command? A comma A is a before event here. Before event observation. B is a after event observation. Comma paired. This is very important. There we have not written. This is a PAIRED. Paired is equal to again true. I am doing this paired comparison. It is a true. It is always in capital letter should be there. Previously I have not written capital letter, hence it was given wrong. Later we changed it. The true should be in capital letter. This is what command. T.test. Open the bracket. A observation is a pre-event observation. B observation is a post-event observation. Paired is a must for this test. Paired comparison test. You should compulsorily write this argument. Paired is equal to. Now, just enter. Enter if you hit answer has come. Now just enter. We have taken paired t-test. What is your p-value? P-value will say. Again 0.9701. What it says? The event before and after, they are same. They are same. They are not different because your p-value is more than 0.05. When your p-value is more than 0.05, we say that there is no significant difference between the pre and post, between before and after. You can take anything. Before dividend announcement, you take share price. After announcement, you take some dividend announcement share price. You can make comparison. You can make n number of companies you can take. Only the thing is you should have a knowledge of data analysis. You can make as many as comparisons. This is what I am saying. This is the difference. Again, same test we are using in a Wilcoxon. Same paired comparison. Again, same Wilcox. that I am writing. So A comma B comma again paired. Again same I am writing. Paired, it has come prompted. What is there in that? True. TRUE. Now same it is a just. If you want to add something else, you can add. I'll say you. If you want to say something, sir, I want to do confidence level at 95%, 99%, you can do it, right? CONF. CONF is equal to, I want to do it at 10% level of sickness, 0.90. I want to do. We can do it. 0.9 to paired comparison. Argument 4 matches multiple formal rare is as come. Wilcox AB paired T true. Confidence is 0. 0. CONF. First confidence. Otherwise, we can make it. This is the first. That is next. If you want to make it, let us see. Otherwise, we'll take it next. Anyway, it doesn't come. Now we'll make it this one. Somewhere 3 matches argument, 3 matches multiple formal arguments. If I take confidence level, it is not coming. Paired comparison Wilcox dot test AB. This one. A comma is observation. B comma, like first paired, we'll take it after that. DRED. Only T have you have written, it has come. TRUE now shortcut is I think there may be command changes maybe there. T. Wilcoxon signed rank test with continuity correlation. The answer is P value is 0.8923. In Wilcoxon also there is no significant difference. Now here also in parametric no difference. Almost all 0.97 it has come in T test paired comparison. In non-parametric it has come 0.89. Same much, there is no much difference. 97, 810 both are not significant difference. This is what we can call it as a t-test, parametric and non-parametric. Shall we go to the now ANOVA, analysis of variance. When it comes to ANOVA, we'll take it one more observation. 3 we want to take already. A is there, B is there. We'll go to the C, one more variable. C is equal to C, collection. Now we'll write it 54 something. I am writing as I like. There is no any hard and fast rules because observation I am writing. No, it is a comma. It's not a comma. It is a full stop I have written. Comma is very important. Comma. Instead of comma, if you write it full stop, it doesn't accept. 1, 2, 3, 4, 5. Yes. After fifth observation, don't make comma. It should be close the bracket. Now C. Now C is agreed. Now I want to calculate now ABC. Now when I want to calculate ABC ANOVA, first what I do, I'll go with now one way ANOVA. Now instead of that I'll go with another way. Now stack X is equal to STACK, stack the observation A comma B comma C. I am X is equal to stack, just wait. x is equal to, I'll first I'll add it all these things into one. X is equal to data dot frame. I'll tell you this with respect to directly I've done data dot frame, open the bracket, a comma b comma, directly I cannot take for that. This is, I have stored everything in this x. Now I'll go with stack. What is stack? Instead of putting the data in horizontal, I am putting the data into vertical. Now what is that? Y is equal to, I am putting this data into y, stack, stack, open the bracket. I am stored data entire IBC in x. I have stored it. Now I am putting in y. Let me repeat once again. If I have any doubts, please I can accept your doubts. I will ask you later also. Now what I did, A observation, A variable, B variable, C variable I have taken. Now all these three variables I have stored in a data dot frame. X I have stored it. That x, all three variables x what I am taking, I am putting into vertical format. Now what is that? If suppose if you write it this x, just I am writing what is x, it will give. Just see. X has come this one. Y is also coming not in this way. It is dividing into ABC this way. You see that here you just look at that columns and rows. How the columns and rows, there are three columns of A, B, C, three columns and its observation. When I put it in stack, it will come all numbers in one line, ABC in another column. Let me repeat once again. Here how it has come. The data dot frame will make all the columns and its observation. A is a one column, its observation. B is a one column, its observation. C is a one column and all has been stored in X. When I convert this X data stored into stack of Y, then how it is come? Just I am writing. Just I am putting Y. Y how it is how it has come. Then see how it has come. All values of ABC in one line. One after A, it has taken up to 12. Then B has taken 5. Next, then C is the last. Here previously it is in the form of row, A variable, B variable, C variable. Next row, again A variable, B variable, C variable. Again third row like this. It is not like that. First A you are taking, all A first up to 5. Next to B you are taking, next to you are C taking. This is what we say that converting ANOVA cannot be done directly. ANOVA should be converted into stack. First, all any more than 2 variables which are there, or even 10 are there, first you store it in one data frame, data dot frame. What is data dot frame? It is a structure of data in R that holds all the data. Data dot frame is a structure of the data in R that captures, that holds all the data. That all the data of ABC is stored in a data dot frame of what is the name? Name of the data dot frame is X. I stored that X I am converting to stack of Y. When I convert into stack of Y, the data has been converted. How it has been converted? First, I have taken all variables A, next to B variables and C variables. One interesting here it is a, what is that? One column is a numeric value, second column is a categorical value. This is very important. It's all advanced I am saying. So if I say many things, sometimes it may be more confusing. So that if you have any doubts, please you can ask me. Here previous how it is data, A, B, C, all are numeric value. Here it is not like that. Columns, one column is a numeric, another column is a categorical. This is one of the important features of your ANOVA. Now let us come to the ANOVA. ANOVA is equal to, I am ready. ANOVA, name of that entire result I am storing in the name of the ANOVA only. You can write some other name also. I told you, first what you write as you like it, you can write it. There is nothing you can write. I am writing M. Yes, M you can write. What is nothing wrong. What is the function here for ANOVA? AOV is a function. Be clear. Analysis of variance. This function is very important. After this function, First you take column of values. Here column name of the one column is a values. Copy it and first you write it that one column observation, comma. Second observation, not comma. Extremely sorry. It is a influence. This word. This is what. This symbol you should remember. Just I am writing once again. This symbol should come. Influence. This one. This is a mathematically we can call this a symbol tilde. THILTA. In mathematically, this function we can call in statistics. If I am not correct, I am saying THILTA. Probably like this word. That symbol name we can call it a tilde. For understanding, for making you people like a layman to understand, we say the word. This symbol is a influencing, impact. Just see, it is there. Where it is there in your keyboard, top first key. First key only this symbol is there. In your keyboard, first key is a that symbol name. Next, what is that? I am writing ind. Be clear. Up to here, only commas are there. In ANOVA, this tilde symbol has come. M is equal to AOV, analysis of variance, open the bracket, first column observation, second column observation, again. Now, you have to just write data name of the data. If you, what is the data name? Because that comma, name of the data is equal to, name of the data is, where is that? Data was there in a R, Y. I am writing Y. Data was there in the Y. It was stored. Now I am writing this one. Now it is correct. Command is correct. Now I am writing summary. This is what additional commands have come in the ANOVA, because this is an advanced one. So that we have additional commands, we got it here. So that you need to learn additional commands. This one. Let me say from the beginning. What is first? 3 observations have been stored in different names A, B, C. That have been all 3 variables have been held in one X data, X name. Then that X data, all 3 will be converted into state. After converting it to state, I am writing ANOVA command. What is ANOVA command? AOV function. First column is a numeric value columns, tilde, ind, second column. Thereafter, name of the data. What is the name you have stored? You have stored in the immediate previous, not in the long. Immediate stored in the Y. Immediate, in which name you have stored? Immediately previously you have stored all the variables into Y. I am writing data Y, not A, not B, not C, not X. It is immediate, previous immediate. In which name you have stored, that you have to take. This is very important. Majority of the people, sometimes they get confused. Next, what you write? Summary. Then you have stored in the which name? M name, finally before. Now M, then you got this is the result. Now here, what is important? Here I told you, here VEF value is there. Here P value is also there. Everywhere P value is very important. Whichever tool you use it in softwares, not only here, any software now P in statistics, now this has become more important. P value. Here P value, what it is? It is a more than 0.05. So that null hypothesis is accepted. Null hypothesis accepted means what? Null hypothesis says there is no significant difference among the means of A variable, B variable and C variable. There is no significant difference among the means of A, B and C. This is a null hypothesis statement. Come to the alternative hypothesis. H1 is equal to any one of the variables. Mean is not different from other means. 1 year, at least, if at least one of the means of variable is different from other 2 variables, then alternative hypothesis is accepted. So here answer is very clear, p-value. So that when p-value has come, it has become everyone is happy who is doing research. Earlier, for every calculation, how we used to see this value, f value, we used to have to see from the table figure. If the table value be clear, this also I'll say how it's old system. This what we can call it is a f value, is a calculated value. Table value we can call it is a critical value. Table value we say the word critical value. In Excel sheet, that table value will also be given. In especially Excel. In Excel, when you do this kind of small calculation like data, there is a one data analysis, one menu is there. If that menu, if you use it in Excel, there we get even critical value also is given. Critical value is table value. You need not go to the table and see. I am here itself. I am giving that. That is what he is saying. Here, what f value is 0.825. This is compared with the table value. Now, if a null hypothesis has to be accepted, means your calculated value should be more than critical value. If you want that also you can write. If the calculated value, f value, what is that? 0.825 should be more. Should be, should be less than your critical value. It should be within your critical value. Let me repeat once again. If calculated value or f value is less than critical value, null hypothesis is accepted. If f value or calculated value is more than critical value, alternative hypothesis is accepted. If somebody wants, you can go and refer this table, ANOVA table, this f value. In two-tailed test, you have to check. Again, this is another one. Because as we know, if you go ahead, many doubts will come. We are all doing in a two-tailed test. What is two-tailed? In both the side, if you draw a normal distribution on both the side, plus or minus, I am saying, plus or minus 5% level of significance is minus side 0.025, plus side 0.025 means 2.5% left side, 2.5% left side. If I add it, it comes 5%. This is called two-tailed test. By default, all the softwares will calculate two-tailed test. Again, question comes, what is one-tailed test? If you want to calculate one-tailed test, you should say your hypothesis testing as a more than, less than. More than, less than. You may be saying mean of A is a more than that of B. Statement has been changed here. Be clear. Statement of H0 has been changed. Earlier I was saying for two tiles, no difference. Same or no difference. Here I am not saying no same, more than. If I say single tile, if I use it, I use the word. I am writing here. For your understanding, I'll write here. Now let me finish it. I'll come to that single tile. Now what I am saying here, 0.46 to say that there is no significant difference among the means of A, B and C. Because P value is more than 0.05. Hence, null hypothesis is accepted. So if you want to make statement like this, I am saying I am coming back to the now more than or less than. Now you may be saying, sir, I want to test like this. Now mean of A is greater than mean of B. If you want to say same test, for example, T test, T dot test, open the bracket, A comma, B comma, are you getting my? Here I use a word, what I am using here, very important. What is that word? Two-sided or alternative. ALT, alternative is equal to more than I am using. More than. I can put it this two-sided, or I can use it in double inverted commas, greater. Greater. This is what is comment. What is this command says? The command says that AB observation T test I am doing. Now alternative hypothesis I am not saying not significant difference. I am saying alternative is greater. Now this is what command I am using. Now when I use it, this alternative ALT also we can do. If you want a shortcut, or you can also do full, you can write. Just let us check. Answers. If you want shortcut also, ALT is equal to greater. Here is very important. Here what is a test statement? Statement I am saying, let me repeat once again. HO in this case, two-sided this one. One-sided, nothing but single tile test. Just you have to ask questions on this. Then only I will come to know that something you have concentrated what I have repeated so far. This is a, whenever I use the word alternative is equal to greater or lesser or two-sided, it means that single tile test. What is single tile test? The statement is HO. I am saying mean of A is greater than that of B. This is a HO statement. What is alternative? Mean of A is not greater than that of B. This is very simple. This is what test it is. Now come to your p-value. Now when it comes to p-value, now here what is HO? Mean of A is not greater than that of B. Means they are equal. They are equal. If the p-value had come, less than 0.05, I would have written clearly. What is that? Mean value of A is greater than that of B. This is what we use it in a single tail test. Very interesting this is all. Now this is what we use it. This is what we can call it as ANOVA. ANOVA means 3 means we take it. Again Kruskal value, same test. Corresponding non-parametric test of ANOVA of parametric test is Kruskal values test. Kruskal values full name. Here command is has come KRUSKAL. Kruskal values test. Open the bracket. Open the bracket. Now all observations you have to write same way what you have written here. Values ind. Directly I will write. Anyway I have changed it. Same I am writing, copying and writing it. Because I don't want to again do it. Copy. Now it has values tilde ind. Ind means index here. Ind means somebody may be asking this question. Ind means index. Index nothing but group. Data is equal to Y. Kruskal values rank test. Now p value has come to 0.4311. Here also what is the ANOVA value is 0.462, 0.431. Both are same. Both p values are more than 0.05. Hence null hypothesis is accepted. It means there is no significant difference among the means of A, B and C. That too median here. Here median is followed especially in non-parametric. I told you. If I said by mistake mean, it is wrong. Among the medians of A, B, C. This is all I am saying. Now this is what you can do it. Now if you want I will continue. Otherwise you just any doubts you have, please you can ask me. Have you any doubts? Any doubts have you? Have you any doubts, please? Kindly give additional examples, sir. Yes, sir. We can hear more. Now, again, what else they want? Kindly give additional example. We can give what is it? Just I take the data from you. Well done, sir. Otherwise, I'll give my this one. What is that? I'll give my all my material. You can do it. That material in material it is there. If you want, you can take. I'll provide material. You can. Now, what is that? Give additional examples. Okay, we can hear more. Okay, next. What is there? Well done, sir. Your presentation is very good, sir. Nice presentation. Please, sir. What else? Please. No, don't prize me. First you ask question, then later you can prize me at the end. No problem. Pricing at the end. Now you ask questions then. So that I feel so happy that whatever efforts I made, you have understood. Now tell me any doubts you have. Shall I go to next or should I end up? I don't know how you. Otherwise, I'll give correlation COR. That also if you want to do, I'll do it. Shall we? Any doubts you have? Shall I go to next? Shall I show the correlation? Now, just I'll go to yes. Now I'll go to correlation. Now correlation is a relationship between two variables. I am saying same two variables for correlation first. Calculation. Now first let me calculate COR. This is what? Command for correlation calculation. I am calculating the relationship of A and B variable A comma P. Simple correlation. Now I'll take it. The calculation has come direct 0.36. Correlation between A and B is a positive. It is a not strong positive correlation. It's a very poor. Poor means how do you say? It is all. There is no any hard and fast rule. It all depends upon your convenience. Below 35 it is there. We can say poor correlation. If it is a more than 60 or 70 is there strong correlation. We say this is the way how we can use it. Correlation between A and B is a 0.3640. For this test also we can do. What is a test? Correlation correlation test. COR dot test. We use it correlation test. This correlation test. What is the hypothesis? Wherever tests are there, hypotheses are set. What is hypothesis? HY is there is no relationship between A and B variable. Second H1 is there is a relationship between A and B. Now I am writing correlation test AB, A variable, B variable. Now what is the method you are practicing? There are three methods are there here. One is Pearson method, Carl Pearson method. One more is a Spearman method. Another one is a Kendall method. This Kendall method is used for non-parametric tests. Are you getting it? Kendall we use it for non-parametric test. I'll use the method just comma. As there are three methods are there, we specify it which method you are doing. METHOD method is equal to what method you are using. That I am writing in a double inverted commas. I am writing Pearson. PEARSON is a method. As we are calculating manually also, there are three methods. Popularly Pearson and what is that? Spearman. But I am using here Spearman. Right. That has come. What is that? P value is 0.5465. What it says? There is no association relationship between A and B because your correlation has come 0.35, 35% something it has come, so that it is clearly say that now HO is accepted since its P value is less than 0.05, and so then we say that there is no relationship between A and B. This one. If you want plots, if you want car plot, COR, car. If you want diagram of this car plot, we use the word. Now car plot A, comma B. Car plot, we use it. Now, if it is a data, if you want, we can write. We have to combine it. This AB. Just I'll do it. We'll combine it AB. What is it? Data dot frame. X is equal to data dot frame A comma B. A comma B. Enter. Now car plot. Car plot is equal to X. This is what car plot. How beautiful it is. Now color has come. This is what many are there here. Heat map is also there. Many are there. You can do something if you want to do. You can do with the different colors also. You can do. Now there are n number of methods are there. Very beautiful pictures will come. If you want to change the color, you can change the color. You can change the this one. All you can do it. Now let me last. I'll go to the chi-square test. Now here I have to chi-square test. Same. We can take it if you want. Otherwise, we can think of. Now I am taking same data. I am calculating same data because chi-square test. What is you are taking chi sq. It has come chi-square test. The command is chiq a comma b. Here also two variables I am taking. Example sake for you. You can use the data as you like. Then chi-square test has come. Pearson's chi-square test p value 0.2202. It says that null hypothesis is accepted. Null hypothesis says that the data are, I told you in the beginning. Now it can be used for two purposes. One is for test of independence. Here we are using for test of independence or association. What is HO says? HO says that there is no association between A and B, or there is a independent. Both are A and B are independent variables. Now this is what we can do it. This is what here it graph is also there. That is a something mosaic plot. Something we use it. Mosaic plot. Just wait. We'll put it that data, everything answer into. Just wait. L is equal to, we'll put the data. We'll put the data, entire result is in L. I'll put the entire result of chi-square test in the L variable. Now, to draw the mosaic plot, let me check this one. Mosaic plot, this is another type of plot. We use it for chi-square. Mosaic plot L. It is stored in L. Let me check. I don't know whether it should. Mosaic plot is not coming. In tabulation, it has come. Bin must be numeric. Sorry. It is a categorical data we need it. Yes. Now, one more data. What is that? Just will plot it. Mosaic under. Okay, this is what plot. If you want, we can do it. Many plots, bar plot, box plot. There are plots are very interesting. Here, last I am doing this box plot of A. If you want, box plot of margin is smaller. Plot. Just come here. It has been joined there. What has happened? Let us check with B variable. Let me check whether it comes. B variable. A variable margin is maybe greater. I think so. That box plot will try it. Color, if you want to do, you can add. I told you, color means you should write color. This for this comma, another argument. Color COL is equal to double inverted commas. Put it. What color you want? I want a gray color. GREY. Gray color. I want it. It will come in gray color. Now, if you want it in a what is that color? A pink color. Pink color. If I want it, you write pink. PINK. Write it pink color. It will come in a pink color. Whichever color you want, you can come. It will come. Now, bar plot you can do. Even histogram also you can do. HIST. Histogram. I am calculating. A histogram of A. It is also another world. Data visualization is another world wherein we can picturize the things like anything. So these are all graphs also, many are there. But one box plot, let me show you that. Box plot is very interesting. Bar plot, box plot. Box plot will tell you about the measures of central tendency. E data I'll take. This is a box plot. If you want color, because this middle line is this is a maximum, this is a minimum, middle line is a median, maximum and minimum. This is what we can call as a Q1 quartile is a Q3 quartile, we say the words. Now, is a more the heighter, more the variance. Is a heighter is less, width is more. When height is bigger is there, we say more variance because its spread is more. So this is what is a more powerful plot. We use it when we want to we use it when we want to describe the data. Like if I want to give color, I can give color also for this. If you want any good color, if I want, I may not be familiar with the colors because girls may be very well in saying colors. It is what blue, green we can give. Green color I want it. I can give green color. This is all how you can do it. Now, these are all I told you, whatever more than what I expected, I have told you. There are many more things I have to say because it's a ocean. It is a slowly we can learn many things, and we can. You have any doubts? You can ask. We'll end up this one. Please, you can ask questions. My job is over. Now your job starts. Any doubts are there? Please. What is Khalil? Provide us the material for further understanding. Okay, we'll do it. No, don't worry. Don't worry, Khalil will provide you. Next time. Well done. Okay. Any doubts you have, please? Now, actually, I have to confine my teaching to 5 o'clock. Anyway, looking at your interest and everyone, I extended up to 5:30. Yes, tell me. Sir.
Sir.
Tell me, sir, anything they want, please, you can say on behalf of them. Anything they want to ask?
No, sir. The participants' time, sir. This is the participants' time to share any queries.
Because doubts are many, no doubt. But unless you practice, unless you read the books, you cannot do any good research. It is itself is a big area. Research, nobody can say that I am the best. It's an ocean, it is. I have written recently article. If you want to, you can go to my articles. In a latest article, management accountant is there is one article is there. You can go. Even one is in Pragna, NIBM article where it has been published recently. If you want, you can refer those. We have written it. Anything doubts are there, please you can ask. No doubts, I think so. Please.
Dear participants, please ask any doubts. Sir is ready to clarify. If there there are no further questions, we will conclude today's session.
Yes.
Thank you, sir, for your inspiring, interesting, and more informative presentation on R programming for data analysis in social science research. Your insights were both enlightening and engaging. Thank you, sir. Now
Thank
I invite Dr. M. Sambasivudu, HOD of Commerce, to present the vote of thanks.
Up today, a illuminating session of the 5-day National Webinar-cum-Faculty Development Program. It is my honor to extend a heartfelt vote of thanks. First and foremost, my sincere gratitude goes to our keynote speaker, Professor Jilani Basha, for his thought-provoking insights on R programming for data analysis in social science research. Your contributions have enriched our understanding of the topic. A special thank you to our beloved principal, Dr. Sister Saini KP, for her unwavering support of this initiative. To all participants, thank you for your active engagement and enthusiasm, which made the discussions all the more meaningful. Lastly, a big thank you to our technical and support teams for ensuring the smooth functioning of this virtual event. Your efforts behind the scenes have been invaluable. With that, I look forward to seeing you all tomorrow for day 3 of the webinar at 3 p.m. Thank you and have a wonderful evening. Thank you, one and all.
Thank you, sir. Thank you very much. Okay.
Dear participants, the feedback link will be posted in the WhatsApp group. Thank you, sir. Once again, thank you all.
Yes, yes, thank you.
Sir, good evening, sir. Vijay sir. Okay, sir.
సార్ గుడ్ ఈవినింగ్ యాక్చువల్గా నేను మైక్ ఆన్ చేయడం మర్చిపోయాను. ఇప్పుడు వినపడుతుందా సార్?
ఓకే సార్.
సార్ చాలా బాగా చెప్పారు సార్. ఇంకా లైవ్ సెషన్ అయితే మనం ఫుల్ ఫ్లెడ్జ్డ్గా వింటే సూపర్ చేసుకోవచ్చు.
2 hours అడిగారు, ఖచ్చితంగా 2 hours
ఏకదాటిగా బ్రహ్మాండం చెప్పారు.
చాలా ఎక్సలెంట్.
విజయ్ బాబు సార్ బాగున్నారా?
సార్ హెచ్ఓడి సార్ ఫైన్ సార్. కాల్ డ్రాప్ సార్. నమస్తే
సార్. సార్, దిస్ ఇస్ ద రికార్డింగ్ సెషన్ సార్.
ఓకే సారీ.
Okay,
thank you sir. Have a nice day. Bye sir. Bye.
Okay sir, bye. Thank you.